Seems good. Alright, let's start project. This is a very short stream. I don't expect it to last too long. Maybe an hour at the most. File, new, project. Project, CPP, no, temp CPP arrays. Add a file, main.cpp. Alright, let's add our basic main. I'll add this for my own convenience. There you go. Alright, so program's running. Alright, so a friend of mine is taking big intro programming classes to C++, and the topic that she worked on recently was arrays. And so I figured after she was done with her homework, which she finished today and she turned in today, I was going to take a stab at it. But while I do it, I will also kind of explain the concepts as I work on it. So basically the challenge is you're given an array, which I gotta type, so hold on a second. Tamales consumed. 21. Oh god. 0. There we go. Big S array. And we'll bring this down a few lines. So given this array, this is an array of 21 guests at a party. And the 21 guests at the party ate these many tamales. So the first guest ate 0 tamales. The second guest ate 1 tamale, then 1 tamale, etc., etc. The last guest on the list ate 7 tamales. And if you notice, this array that they've given us is already sorted, and it's guaranteed to be sorted. So given this array, I'm supposed to find the mean value of the tamales consumed. And I'm also supposed to find the median of the tamales eaten. But they don't mean, strictly speaking, the mathematical mean and the mathematical median. They want you more interested in doing what you're doing with the array. So let's say for the mean they say display, I'll do / on this one. Display the mean number of tamales consumed by party guests. That is the sum of all the tamales consumed by all the guests divided by the number of guests. So for example, when you usually do a mean, you expect a fractional answer, but because we're working with integers here, I assume that the professor who gave this homework is going to be fine with a integer result. Alright, so with this one, they want us to, if the number of tamales eaten by each guest is placed in order as it is, then the median is the number of tamales consumed by the middlemost guest. For 7 guests, it would be the number eaten by the fourth guest if you arrange guests in order of tamales consumed. Alright, so let me fix the formatting here. Jeez. Alright. So first we're going to display the mean value. So we need a way to add up the total amount of tamales eaten. So I'm going to make an integer called total. And so let me brush line thick black. So if this is our program, I just made an integer variable called total, and I assigned it the value of 0. Alright. So now I need a way to loop through this array no matter how big or small the array is. Fortunately, there's a way to do that in C++. I want to say you do this for int current guest tamales consumed. Is that how you do it? It's been a while. Yeah, okay. Loop through every entry in the array. Add their tamale consumption to my total. So total plus equals tamales consumed. Oh, sorry. My bad. Nope, that's not how it works. Don't be stupid. The integer is current guest. My bad. So when this for loop finishes, my total is now equal to the total amount of tamales consumed. But the downside is, for me to get the average, I need to know how many guests there were. And I wasn't keeping track of that in this loop. So I have two options. I can either rewrite this for loop, I can calculate the amount of entries, figure that out first, and then rewrite this for loop to do it that way. Or I can just figure out how many people there are now, after I've done the loop. It doesn't matter either way. No matter what, I have to figure out how many things were in the array. So to do that, you can do integer numGuess is assigned the value of. Take the size of the whole array and divide it by the size of the first guy in the array. Yes, kitty cat? Come here. How are you gonna meow at me? Okay, fine, don't come over here. I didn't want your love anyways. So now that I have the number of guests and I have the total number of tamales eaten, I can calculate the actual mean. So I'm gonna say int mean is equal to the total divided by the number of guests. But I'm gonna play it safe, and I'm gonna put a safety check that says if the number of guests does not equal 0, then I'll divide by that. Because if you have 0 guests, you would be dividing by 0, it would crash your program. So we're gonna give that a shot. I'm gonna see out all these values. See out total, and no, don't do that yet. Oh yeah, do that. Alright, so see out number of guests. Guess. And I'm gonna see out average, or I'm sorry, mean as they call it. I've always called it average. I don't even like the word mean. I think mean is mean. Alright, so when we run this program, oh, I've already got a build error somewhere. Oh, good point. My bad. There. So when I run this program, I I had a total of 55 tamales. The number of guests was 21. That gives me a mean of 2. So let's pull out the calculator and verify our math is right here. So I'm going to say 55 tamales divided by 21 guests is 2.619 tamales per person. But because this is integer math, there's no fractional part, so it's just 2. So the math works. Alright, so let's move on to the next exercise part, which is find the median of the tamales eaten. If the number of tamales eaten by each guest is placed in order, as it was, then the median is the number of tamales consumed by the middlemost guest. For 7 guests, it would be the number eaten by the 4th guest if you arrange guests in order of tamales consumed. So I've already got the number of guests, which really helps out. I can take int chosen index, and I can assign it the value of num guests divided by 2. So let's see. If we had 4 people, that would give me an index of 2. If we had 7 people, that would give me an index of 3, this is actually the 3rd person. This would actually be the 4th person, because indexes or arrays in C++ start at 0. So something I need to be cautious about is if we have an even amount of people, I need to subtract 1 from the end of this. So let's do that. So let's see. If number of guests modulus 2 equals 0, even number. Alright, so figure out the middle number, which is dividing by 2. Then, if this is an even number, then chosen index minus minus. So that will give us the correct index to spit out. So let's see. I'm gonna see out first let's put out a nice little sexy line to separate what I already previously had, and I'll put that up here. There we go. Alright, so now see out number of guests, num guests, and then I also want to spit out the halfway point, which would just be num guests divided by 2. And then I finally want to spit out chosen index, which would be chosen index. Let's see how median tamales consumed, which would be what the hell's the thing called? It's called tamales consumed. Sub-chosen index. Build. Run. Alright, so let's see. I know you guys probably can't see this font. It's a little small. It says the number of guests were 21. So the halfway point of 21 divided by 2 is 10, which is correct. The chosen index therefore becomes 10 because I only subtract 1 if it was an even number. 21 is not an even number. So now it says the medium tamales consumed is 2. So what I should do is check index 10 in that array and make sure it's 2. I know it will be though, but still. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. It's a 2. So that's how you could do it. And that's the way I think the professor probably wanted them to do it. But there are other more complicated ways you could do this. Alright, so that was the easy way. Now I'm going to do a little bit more difficult ones. So now we're going to do the optional hard mode. So the optional hard mode says use a vector instead of an array, and then use a loop to allow the user to enter custom data for our tamale eaters. The user should be allowed to continue adding numbers for guests until they run out of guests, at which point they should be allowed to enter -1 to stop adding guests to the vector. Warning: if you have not entered the data in order, finding the median will become harder. For this hard mode, assume that the user is going to input data in order. Alright, so let's do that. And first, I'm going to go ahead and hide this code, even though it was nice. Pound if 0. And then I'm going to go down here. Pound end if. There, this way I can hide this old code. It's still there, and I'm going to label it as easy mode or normal mode. Not sure what it's called. Now we're going to do hard mode. Alright, so hard mode tells me I should use an array instead. So I'm going to go ahead and pound include, or I'm sorry, use a vector instead. So I'm going to go ahead and pound include vector. Alright, and it says the user should be allowed to continue adding numbers to this vector. So I need to set up some sort of way for the user to give me numbers over and over until the user tells me he wants to stop. So first, let's create our vector of numbers. I'm gonna call it Tamales consumed again. That seems pretty fair. Tamales consumed. Alright, so now have the user input tamales consumed. So I need an integer for this. Int eaten. I'm gonna set it to 0 first. And I'm gonna say I'm gonna tell the user, please enter an amount of tamales consumed by this. That's too much. How much did you eat, yo? Alright. And then I'm gonna take the user's input and I'm gonna store it into this integer called eaten. Then, after that's done, I'm gonna assume, because I'm already assuming that they're going to enter these numbers in order from smallest to largest. So I'm also going to assume that they've given me good input. I'm going to take that number, and I'm going to push it into the array of tamales consumed. But I have to be careful, because if the user has given me the number -1, he didn't mean to say that the user ate -1 tamales. He's saying that, sorry, hold on. He's not saying that the user ate -1 tamales. He said the user's saying, I want to quit entering stuff now. So I'm going to say if eaten equals -1, stop somehow. Push number into array. Alright, so the next... What the hell? What's wrong with that? See out. How much did you eat, yo? What? No, it's not. You're talking about see out is ambiguous. What the fuck? Build, you're being weird. Yeah, see, that's what I thought. Did I misspell see out or something? What the fuck? Okay, now I'm very confused. Oh, can you not take... Yeah, you can take that. I've done that before. What are you talking about? What the fuck? Oh. No, that should be good. What the hell's going on here? I've already got a problem. That's weird. I've got a weird issue already. How is see out ambiguous? I've pound included. I'm using it. Here. I'll be even more specific. Use see out. Using cin. This is also better anyways. You don't want to freaking pound include 50 things if you're not gonna... Okay. I'm so confused, but that worked. Alright, whatever. Weirdness. Alright, anyways. So this will take one number from the user and stuff it into the array. If it's -1, we have to stop somehow. And also, we have to keep doing this over and over. So in order to keep doing this over and over, I'm going to make a while loop. And I'm just going to say, I'm going to hard code it, while true. So this thing will loop forever. However, if the user enters -1, I'm gonna break out of this loop by fucking breaking. Alright, what's going on here? I wander in at 1:30 a.m., completely out of it because I'm drugged up on NyQuil, and I see a whole bunch of text that makes no sense to me. You're talking about tamales, and there's dramatic background music. Am I hallucinating? No, you're not hallucinating. Yeah, oh yeah. Alright, so... I mean, there's a lot of things you can give me shit for, Frantic, like the fact that I'm assuming that the user would give me good input. But I mean, that's literally what this homework is saying. Hey, this user, not only is he going to give me good input, but he's going to give me the array in order. That's Paul, by the way. How are you doing? I'm doing good. How have you been, dude? And I don't recognize your username. Didn't you used to be Alucard, I think? Alright, so now that this loop is over, the vector now has all the guests and their tamales consumed in order, which is nice. Yeah, that's it, Captain Planet, damn it. I couldn't remember that anymore. My bad. Why did I think Alucard? I don't know. I know you know who Alucard is, though. You used to recognize the voice of the voice actor, Crispin Freeman. Alright, so then you would move on and do the rest of the exercise, which was calculating the total, the average, the mean, and then calculate the, what was the other one? The median, yeah. Yeah, there we go. Yeah, I'm telling you, Crispin Freeman is a great voice actor. I know him from Star Ocean 3 as, well, Albel the Wicked. And the main hero of Gothic 3. Okay, so yeah. So for calculating the mean, once again, we have to somehow loop over this information. So we can do for unsigned int current guest, assign the value of 0, as long as current guest is less than our tamales consumed. Now what's nice about vectors is they come with a list, a crap ton list of useful functions. And one of those for looping over them is the size function. Current guest. Alright, come on, fix yourself. I'm gonna zoom out just a little bit. There we go. And total equals 0. Total plus equals current guest sub current guest. Oh shit. Tamales consumed sub current guest. Int what I call it, medium, mean. Why can't I remember that fucking word? I don't like the word mean. That's all I gotta say there. Int mean, assign the value of total divided by the tamales consumed dot size, but we'll put a safety if check around that. Tamales consumed dot size is not equals 0. So if you give me no guest, I'm not gonna give you any answer at all. Keep doing that. And then I'm just gonna steal the old code for spitting it out. Copy. Boop. And paste. Boop. Total. Oh yeah. There you go. There you go. Define you're at least bilingual, cause it's C++. Sorry, I'm doing a coding thing. Put a if around the entire calculation logic. I thought I did. You talking about around the for loop too? I mean, I could. Doesn't matter. Num guess is now tamales consumed dot size. Cool. Now, how does the median go again? Okay, the median, I'm just gonna steal the old code again. This is one lesson that you need to learn as a programmer. you will use and steal code all the time. If you don't want to have to write it again, you don't have to. That's one of the nice things. I don't think she's learned functions yet though, so I won't be using any functions. Not yet. So just give me all that. Number of guests. I didn't make you. Why do you know what that is? I don't think it's seeing my if very well. Yeah, that's very strange. So confused. Modulus 2 equals 0. If it's an even number, chosen index minus minus. There you go. That should be perfect, actually. Does it build? Run. Yeah, got the main function. You're right about that. You see out a sexy line separating them, otherwise I won't see the difference. Alright, so this should run and it should ask me to just start entering numbers. How much did I eat? 3, and I have to enter these in order. So 1, let's say 3, another 3, 7, 8. These people eat a lot of tamales. 8, 8, 9, and then we have the one freak who ate 100 of them. Alright, now I'm done entering tamales, so I'm going to type -1. There we go. So the total amount of tamales consumed was 147. I've entered 9 entries, so I have 9 guests. The average is 16 tamales. Let me check the math. 147 divided by 9 is 16.333, which in integer math gets truncated, so it's 16. That is correct. So now next, the number of guests is 9. The halfway point would be index 4, which means the chosen index is index 4, which is the 5th guy. So let's see. 1, 2, oh, I'm sorry, 0, 1, 2, 3, 4, so it should be 8. Median tamales consumed, 8. That's correct. So there you go. I just did that exercise with a vector in hard mode. Now we're going to go for optional harder mode. Optional harder mode is to do hard mode, but do not assume that the data is in order. You may have to sort your vector after the data has been added. That means you might need to look up a sort algorithm or make one up yourself. Alright, so let's do that. So here's what we're going to do. We're going to copy 99% of this code. Actually, we're going to copy 100% of the code. Harder mode. Alright, so we're still in the exact same place as hard mode, but the only difference is after I've gathered all the user data, right here I'm going to sort the user data. So yeah, I'm basically going to do a bubble sort. Alright, so let's draw up the situation here. Alright, give me, yeah, sure, marker. So let's say this is our vector. 1, 2, 5. It was 6 entries, so we'll say this is a 0, 3, and we'll do another 3, 5, 8, and 10. Oh, god damn it. I sorted it in my head by accident. God damn it. Undo. Alright, so let's try that again. This is I have a harder time making random unsorted. So we'll say 3, 1, 5, 8, 7, 2. Alright, so this array is not sorted. So we have to find a way to sort them. So we're going to go step by step through this. What we're going to do is we're going to loop over every entry in this vector for unsigned int II, I'll say, oh yeah, II is equal to 0 as long as II is less than the tamales consumed.size plus II. So there's nothing new here. This is a simple loop through the array. So it's going to go 0, 1, 2, 3, 4, 5. Now, while we're looping for every entry, we're going to do another loop again. But we're not going to start on the same number. So for unsigned int jj equals 0, jj is less than tamales consumed.size plus jj. Why did I start it? Didn't I just say I wasn't going to do that? Plus 1. Hello, Dandy McGee. And so now what we're going to do is we're going to compare this guy with that guy. And I know it's very hard to explain, but basically, let's say that red is II and that green is JJ. So II is the red loop, and it's going to go 3, 1, 5, 8, 7, 2. Whereas green is JJ, and he's always going to start 1 after red. So when II is on 3, JJ is going to start here on 1. On the next loop, when II is starting at 1, JJ is going to start at 5, etc., etc. So what we're going to do is we're going to compare, are these two, is the index at II less than, or is the guy here less than the guy there? And if so, we're going to swap them. Yeah, I can give them better names. I'm not sure what the hell to call them, though. First loop, second loop? I mean, there's no good names for them. Right? Bob, oh, I know who this is now. How's it going, Ravenos? Oh, God. Wait, what? That can't be you. Oh. Alright. Well, then you give him the name. I don't know what to name him. I'll stick with your suggestion here. We'll do Bob and Susan. There you go, Bob and Susan. Hope I fixed that right. Alright, so now we have Bob, which is red, and I'll even put it up here. Come on, dude. Bob. And then we got green, which is Susan. Alright, so anyways. So as Bob goes through, first Bob is starting at 3, so then Susan starts at I. And what it's going to do, it's going to say, is Susan less than Bob? If so, swap them. And then Susan is going to move down the line to here. Come on, dude. Why are you fighting me? So to here. Give me that. And then it's going to repeat. It's going to say, well, is Susan less than Bob? If so, they'll swap. And then Susan will move on. Is Susan less than Bob? If so, they'll swap. All the way until she gets to the end. Then her loop will finish. And then after her loop finishes, Bob moves on to his next one. And then Susan once again will restart. She'll start at one more. And then once again it'll compare you to you versus you to you versus you to you. And so we're going to see that in action. Move. There we go. Alright, so you know what helps? It helps if I actually code it. I haven't coded it yet. Is Susan less than Bob? If tamales consumed index. You know what? Bob and Susan are better names. Thank you for that. Is less than swap them. I don't like typing tamale. That's one of the things I'm discovering about this exercise. I don't know, the word tamales just doesn't roll off my fucking fingers very well. There you go. Yeah, I'm in total agreement, Dandy. Alright, so now this should work. When this finishes, when this double for loop finishes, we will have a sorted array. And even though I feel like, well, I didn't really cover it very well, I'm still going to go over this on pen and paper first. So let's pretend like this is my array, and we're going to do this in paper. So I'm going to put stuff down here. They don't count when they're down here, okay? So the first for loop starts, and it's Bob, and he starts at 0. Then the next for loop starts, and it's Susan, and she starts at Bob plus 1. So there we go. Now, the first thing in Susan's loop is Susan less than Bob? Which in this case it is. So if they are, they swap. So you're going to go over here, and you're going to go over here. And that's the end of the first loop of Susan. So now Susan's going to move on. Is 5 less than 1? No. Is 8 less than 1? No. Is 7 less than... Yeah, I'm doing a bubble sort, Dandy. Is 7 less than 1? No. Is 2 less than 1? No. So Susan finishes her loop. Her loop is over. Now Bob moves on to the next step in his list, which is 3. And then, immediately at the beginning of his loop, Susan starts another loop. And the process repeats. 5 less than 3? No. 8 less than 3? No. 7 less than 3? No. But 2 less than 3? Yes. So these two are going to swap. And now Susan has finished her second loop all the way through. Bob moves up, and we're just going to keep doing this. And you're going to notice a pattern with the large numbers and what this is called a bubble sort. And you're going to notice a pattern with the large numbers here. So Susan starts her loop again, which is 1 more than Bob. Is 8 less than 5? No. 7 less than 5? No. 3 less than 5? Yes. So they swap. Susan finishes her loop. Bob moves up in life. So this one should be a good one. So right when Bob starts his loop, Susan starts her next loop. She always starts at Bob plus 1, so that's here. Is 7 less than 8? Yes. So they're gonna swap. Hey Asia, how's it going? Then Susan moves forward. Is 5 less than 7? Yes. So they're gonna swap. And then Susan finishes her loop. Bob moves forward in his loop. Right at the beginning of the loop, Susan starts her loop, which is Bob plus 1. Is 8 less than, or 7 less than 8? Yes, they swap. Bam. Susan finishes her loop. Bob moves on to the next one. Right at the beginning, Susan tries to start her loop, but her loop isn't going to go anywhere. So this shit ends. And now look, our array has been sorted. 1, 2, 3, 5, 7, 8. It's a numerical order. So now, all the rest of the code still works like it used to, except now we have a sort that's going in here, and it's called the bubble sort. And the reason it's called bubble sort is because as this thing is slowly sorting your array, it looks like your big numbers are bubbling up to the top of the list. And there are actual visual representations that you can do of sorting. And I'm going to pull up the bubble sort now just to show it off. Bubble sort graphic. I'm sure they got it. Alright, so here's a big array of numbers being sorted via the bubble sort. And you'll notice that the big numbers will kind of bubble up. So here's the big numbers at the end on the right side. You see how they're bubbling up over here? So the big numbers bubble up, and that's why it's called the bubble sort. And it's doing the exact same logic that I just stepped over in the MS Paint. Yeah, you're right about that. Same concept though, it bubbles as it sorts, one way or the other. And boom, it's sorted. So that's the bubble sort in a nutshell. And there are a few, yeah, I do love those videos are awesome. They have another one that does like a bunch of colors, like a circular color wheel. That one's beautiful to look at. Especially if you look at something like gnome sort. Let me see if I can find that one. I think it was bubbles. Just do bubble sort graphic. Really? You misspelled graphic? This one. This one. I love his sorting videos because they just look beautiful. So this is selection sort. He has the sort in the top left corner. But yeah, when you get to the gnome sort, it is fucking gorgeous. Alright, but yeah, I'm gonna move on. Alright, so if I run this, it should work. Let's see. Let's enter a number. Let's enter we gotta enter them out of order. So we'll do 5, 3, 1, 7, 9, 8, 4, 2. There's no way I'm going to be able to check this. Alright, so the total is 39. I'm going to assume that's right. The number of guests was 8. Calculator up. 39 divided by 8 should be 4.8. It's 4, it's correct. Number of guests was 8. The halfway point was 4. which means the chosen index is 3 because that is the 4th person. Median tamales consumed 4. I'm going to guess that's right. Let's see. Lowest number 1, 2, 3, 4. That's correct. Alright, good. This is stable algorithm? I don't know what you mean. Alright, let's see. Alright, so that was the optional harder mode. Now we're going to go on to the optional insane mode. And so the optional insane mode is do harder mode, but also display the third of the most common points of central tendency, which is the mode. This is the most common number of tamales eaten by guest, or the number that appears the most often in the array. This one is kind of tricky, hence the insane mode, but if you know what you are looping over each time you traverse the array, it is doable. If you insert the same number twice, does it maintain the original ordering after the sort? 2 first, 3 second, 3 third. What would happen is index. Does the second come before third? It would be, in that list you gave me, it would be second, first, third. That's what it would be, Dandy. Second, first, third. In the list you gave me, where 2 is first, and 3 is second, and 3 is third, the final list would be 2 first. Oh, I'm sorry. It would be first, second, third. They wouldn't switch at all. Sorry, I got confused. Because if you see here, I'm only swapping if the number is less. If the number is the same, they won't swap at all. Okay. I've never heard of that phrase, stable. Alright, I'll be right back. I need a drink. Alright, I'm back. I have to drink water. I hate water, but I gotta drink it. I gotta drink a lot of it, which sucks. Also, my pain meds are starting to kick in. My hands feel nice and warm. Alright. So anyways, that was, what was the mode? Hard mode? Or harder mode. Let's copy all the logic in it. We'll do insane mode. Copy. Minimize. Insane mode. Pound diff 1, pound in diff. Turn off this one. There you go. Paste. Alright, so what was the difference? I've already forgotten. Let me see. Insane mode was do hard mode, but also display the third of the most common points, the mode. Mode is the most common number of tamales eaten by guests, or the number that appears the most often in the array. This one is kind of tricky, hence the insane mode, but if you know what you're looping over each time you traverse the array, it's doable. Alright, so I got that. Yeah, I hate water. Why do I have end if twice? Did I count? Oh, I copied the end if, huh? Bam, problem solved. Alright, so we've calculated the mean, we've calculated the medium. Now we're just gonna calculate the most common number. Now, if you wanted to be efficient, you would try to do all these calculations in a single for loop. You don't want to do what I'm doing here, where I'm going for loop, for loop, for loop, for loop. You know, I'm basically looping over the whole thing each time I want to calculate something. You wouldn't want to do that. You'd want to try to do it all in a single loop. But because this is a homework exercise, I'm just kind of showing off how you would go about calculating each individual one. So let's say we have an array. Once again, though the numbers are going to have to change. Alright, so let's say our numbers are 1, 2, 5, 2, 5, 3. And an extra one. 2. So here, if we look at this array, I've got 1, 1. I've got 3 2s. I've got 2 5s. And I've got 1 3. The most common number in this array is 2. It shows up 3 times. And that's what they want us to figure out. They want us to look at this list and figure out which number is showing up the most. And so the way we're going to do this, let's see. Easiest way would be to once again do 2 loops. Kind of. Well, sort of. Alright, so one way we can do it is we can keep track of the number of appearances. Num appear. And the current champion. Champ. What's going on here? There may be no mode if no value appears more than any other. There may also be 2 modes, bimodal, 3 modes, trimodal, or 4 modes. What's the point of that? I'm gonna go ahead and quote Ricky Bobby on that one. If you ain't first, you're last. Well, unfortunately, for this homework assignment, there's only 1 mode, and it's just the guy the most. And it also doesn't say what to do in the case of a tie, so what I'm going to do in the case of a tie is I'm just going to show the first guy. Over and over. Are you still the last? Don't know what you mean there. Alright, so what we're going to do is, right at the beginning, we're just going to assume that the guy in the first index is the world champion. So we're going to say the champ is number 1, and he appears at least once or something. I don't know. Then we're going to do a for loop, I guess, right? So then we're going to say, I guess once again we're going to need Bob and Susan. Are we going to need Bob and Susan? And we're going to say for each one, we need a current. At the beginning of the loop, we have a current. And if he's equal to that guy, plus to him. So he starts 1 as 1. And a contender, I guess is his name. Contender. Bunch of ones. So then, as this loop goes along, is 2 the contender? No. Then move on. Is 5 the contender? No. Move on. Is 2 the contender? No. Move on. 5 the contender? No. 3 the contender? No. 2 the contender? No. So then that ends. Yeah, we definitely need a double loop. So then we start again, but we start at 2. 2 becomes the new contender. You gotta go. And yeah, it shows up once. So 2 becomes the new contender. And we say, is 5 the contender? No. Is 2 the contender? Yes. So then we plus this guy. And he will become showing up twice. Then we move along. Is 5 the contender? No. Is 3 the contender? No. Is 2 the contender? Yes. So we plus them. So now we have 3. And at the end of the loop, we'll say, hey, does this contender, who shows up 3 times, does he appear more than the current champ? In which case, yes, he does. This 2 shows up 3 times, whereas the current champ, who's 1, has shown up once. So what happens is he gets replaced. So number of appearances is now this guy. 2 is now the new world champion, basically. And then you start the whole process over, but with 5. So 5 is the new guy. I need to get to using Roman numerals here. And he shows up once. Then you move along. Is he a 5? No. Is he a 5? Yes. Contender goes up 1. There you go. 2. Is he a 5? No. Is he a 5? No. At once the loop ends, does the current contender, who is 5, does he show up more than our current champ? No, he doesn't, because 5 only shows up twice, whereas the champ shows up 3 times. Therefore, our current champ is still the champ. And then it moves on. And it does this for the whole loop. Now, the downside of this logic is that I would be doing the same number a few times. So 2 would be like champ. Let's see. Basically, 1 would be the champ, and then 2 would be the champ. 5 would not be the champ, and then 2 would be tied with the champ, even though the champ is himself. Now, if I want, I could add an if check that says, hey, if this number is equal to the current champ, just don't fucking bother. Move on to the next one. And that's probably this. Oh, God. Uh-oh. I think this pill just made me nauseous, too. And I think that would probably be the best way to move that. So let's code that. Even though it's got its flaws, it will work. So let's do it. For unsigned int Bob equals 0, as long as Bob is less than the array whose name I forgot. Tamales consumed. Equals, what am I doing? Dot size. Plus Bob. And I know I'm doing a bad job explaining this. I'm sorry, guys. You guys deserve better than that. Susan. Susan, don't fuck that up. So we have int champ total, which is 0. We have int champ, right now 0. Int contender total, 0. Int contender, 0. Now before we even begin, we're gonna assume that the champ shows up at least once, and that the champ is index 0, which, by the way, assumes that they entered at least one entry. Bracket 0. And I can put an if check around that if I need to. If it's greater than 0. There you go. Bam. Alright, let's see. Yeah, it's actually a little more complicated than I thought it would be for beginner programmers. Alright, so let's see here. What was I gonna do? I done forgot my logic. Okay, so this starts for... Contender is assigned the value of tamales consumed sub Bob. I'll just go with that. If tamales consume... I hate tamales. I don't know what it is about that word. I can't type tamales. That's a new thing I've learned about myself doing this. Tamales consumed sub Susan is equal to the contender, then the contender total plus plus, and I need to reset that every loop. Apparently I can't spell contender either. Once that loop is over, if the contender total is greater than the champ's total, then congratulations, the champ is now the new that contender. Did we beat the champ? New champ. For every entry, let them try as a contender. Count how many times they appeared. There we go. So when this is over, I should have a champ and his amount. So let's see. Cout champ entry is champ. Cout champ amount of champ total. And I totally didn't save that. Wow. Champ total equals contender total. Good job. That would have sucked. Alright, so I don't care about the entry stuff. All I care about now is which number shows up the most. So we're going to copy my logic here. We're going to enter these numbers. Ready? Run the program. How many did I eat? I entered 1, then a 2, then a 5, then a 2 again, then a 5 again, then a 3, and then a 2. And that's it. So -1. Alright, so the champ entry was number 2. He showed up 3 times. That is correct. It looks like the logic is fine. So that would be the insane mode. And like I said, there are ways I can make this more efficient. One way I can do is if the contender is equal to the champ, don't do the loop again. Because right now, 2, he wins the championship, and then some other guy goes, and then on the next round, 2 actually goes up against himself, which makes no sense. He shouldn't have to go up against himself. But I don't care enough to fix it, so we're good. So that's insane mode. And so that's all of them. I'm sorry I didn't explain them very well. I kind of had a different... I had a different mindset going in, and then I think the drugs kicked in, and then it's actually a little hard to think. But that's okay. I'm feeling pretty good. My hands feel really slow and warm. It's awesome. Alright, so I'm going to try to take this time to talk about arrays and what they are, because I know I didn't do a good job with that. So we're going to cut this now. Bye. Sublime. MS Paint. MS Paint? Are you telling me I closed Paint? Why? I would never close Paint. That's bullshit. You're lying. I wouldn't close Paint. Alright, so let's go. I don't need vector anymore. Alright, so in C++, you have a program. So let's say this is your program. Should I mention the heap? I'm not going to mention the heap right now. So let's just say that this whole window here, this whole fucking, really? Let's just say this whole fucking window here is your program in memory. So this is your program, this entire white box, okay? When I do a line of code like this, integer x equals 0, what I'm doing is I'm telling my program to allocate space in my program, call it x, and assign it the value of 0. And this variable that I've created, he takes up a certain amount of bytes. Like, for example, I know that this integer is 4 bytes. So my program now has allocated 4 bytes of its space and set those bytes to be the value of 0. Alright? Now, that's good and fine when I have, you know, different things that I might want to set to whatever value. So like char initial is A, bool have teeth is fucking true for now. Long, what is this? 70, etc. So just a bunch of different variable types. But let's say that I want to have, I'm okay. Let's say that I want to have a bunch of the same kind of variable for the same kind of thing. So for example, let's say instead of having a single number for age, I want to have 5 numbers for age for 5 different people. Instead of having to go int age 1 equals 34, whereas my friend age 2, he's 32. Oh, and then I have my young friend age 3, he's 30. Etc. And then in age, you know, instead of doing this is kind of tedious, right? We have the old guy in the group. So what that's doing is that is creating a bunch of variables. Int age 1, int age 2, int age 3, int age 4, int age 5. And we're going to shorthand their name here, because that's a lot of typing. Oh god. So let's say this was int age 1, which I'm just going to call A1, age 2, A2, age 3, H3, age 4, and age 5. Now, it created all the age variables that I need, but if you notice, where they're located in memory may not necessarily be close together. So this 4 bytes of space may not necessarily be close to this 4 bytes of space. For all we know, A2 could be way the fuck over here in memory. I'm talking about in RAM, in your RAM. The location of these variables are not, you know, guaranteed to be close. So let's see, I set age 1 to be 34. I set age 2 to be 32. I set age 3 to be 30. 4 to be 31. And you to be 70. So what's different about this, there's a feature in C++ that we call arrays. And arrays allow you to make a bunch of variables by simply specifying a number. So with this line of code, I have created your program will allocate exactly the amount of bytes you need for your variables. How many is that? 5, 2, yep. So 1, 2, 1, 2, 1, 2, 3, 4, 5. Good. 34, 32, 30, 31, 70. And what's nice about this is, in regards to the amount of bytes and their location, each int is 4 bytes. So this is 4. Oh, come on, damn it. This is 4 bytes. This is 4 bytes. 4 bytes. 4 bytes. 4 bytes. So in the end, the amount of space is the same. It's 20 bytes of space, which is nice. But more importantly, the memory locations of these ints are together. Let's say this was like address 10, then this guy is 4 bytes away from address 10. He'd be at address 14. This guy would be at address 18. This guy would be at address 22. This guy would be at address 26. They are all connected, basically one after the other. And in C++, it's called contiguous. The memory is contiguous. There's no gaps in it. It's not like a box here, some empty space of bytes, and then a box here. You know, maybe there's a string here that says hi in memory, and then another frickin' thing. It's not like that. With arrays, your memory is contiguous and connected. And that is a question I'm sure you'll see on your test. Contiguous. Don't forget that word. Contiguous. I think I spelled that right. Actually, I think I might have got that like that. Contiguous. There you go. So that's the neat thing about arrays. Now, the question then becomes, well, then how do I access and set these arrays? Because when I had the 5 variables, if I wanted to set them, I'd just say age 1 equals, this. Age 2 equals that. It was that easy. Well, with arrays, you have to say the name of the array, which we called age, and then you do a bracket, and you put which one I want to edit in here. So 1, or number 2, or number 3. But there's a trick to this. And the trick to this is that arrays start counting at 0. So the first guy, he's index 0. The second guy, oh god, I'm going to throw up. He's index 1. Third guy, index 2. Fourth guy, index 3, etc., etc. So when I have an array of 5 integers, the minimum, the smallest index, the first index, he's 0, not 1. And the last index is 4. And there's a very common mistake in programming known as the off by 1 count, and it's usually because of shit like this, where people forget that arrays start at 1. So if I want to change the first number in that array, I would say age bracket 0 is assigned the value of my new number. So I'm going to say 40. If I want to edit the last guy in the array, I would do age bracket 4, assign the value of, I don't know, 60. He got younger. So this would be how to assign a value to a particular int in the array. And this would be how to access a particular value in an array. As I should say, particular int. So if I wanted to access it, I could do age, bracket, whatever, and that gets that entry. So if I do cout age sub 0, it's going to find the number that's at index 0, which is that 34, which turned into 40, and it's going to spit it out to the screen. So when I run this, I should see 40 written to the screen. 40. I know you guys can't see that font, it's fucking tiny. So that's how you access it. Let's see how to assign it, how to access it. What am I forgetting, guys? What am I forgetting with tutorial-wise? How to initialize it. Oh, okay. Here's something. You may not always know how big your array is. So for example, let's say that we were given an array of, I don't know, of blah. And we don't know its size. I know you're going to be able to count this. But let's say that, you know, we didn't count this. We just don't know how many there are. Let's say there are thousands upon thousands of entries, and we don't have time to count it. Well, there is a way that you can get the size of this array without knowing it. And that's by taking advantage of something called the size of function, which is built into C++. It's a part of the standard library. And so let's make my array here. Yeah, I guess I can just get rid of you. I'm gonna miss you. Goodbye. Alright, so let's pretend we have an array here. And this time, yeah, we're good. This time we have no idea how many indexes there are. Dot, dot, dot. And at some point we assume there's an end to this array. So we got numbers in here like 3, 5, doesn't matter. And then way at the end some other numbers, 7. So the question becomes, how do we figure out how many indexes are in this array? And like I said, in C++ there's a thing called size of. And what size of does is you give it something and it will tell you how many bytes of space it takes up. So if, let's say I call this array X and I say size of X, it will tell me how many bytes it takes up. So maybe it'll say 20 bytes. And so that doesn't quite answer my question. All I know, it doesn't tell me, you know, how many things were in this array. All I know is that however many things there are, I know it takes up 20 bytes. But what's nice about that is now, if I can just figure out the size of one of these things, I can do some math to figure out how many there are. Hello, Doglin Ha 666. Sorry, I probably fucked your name up. So, if I were to then say the size of the first guy, X sub 0, and let's say that comes back with 4 bytes, I now know that the whole thing is 20 bytes, and one of these guys is just 4 bytes. So now I can simply do some math. Okay, so if the whole thing is 20 bytes, and one of them is 4 bytes, then I can say 20 divided by 4. There are now 5, I know for a fact now, there are 5 things in this array. What's up? Is this? It's kind of a lecture, not really. I just, I guess you could say it's a lecture. It's a half-ass lecture. How's that? That's the best way to describe it. So, for example, cout, the size of an int is size of, and we're just gonna hand it an int, right? So let's give it a blah sub 0 here, and a new line. So I'm gonna run that real quick. I gotta jack up the font size. I know you guys can't see that. Hold on. Properties, font size. Wow, really? That's better? Are you kidding me? Well, at least now you can read it, but the program's like 8 fucking miles long. Alright, so when I run this, 40. The size of an int is 4. So now I can take that blah, cout. The size of the array blah is size of blah. gonna delete that old cout. You're gone. So now it tells me the size of the array blah is 24, and it's always in bytes, so 24 bytes. So now, see out, the size of a single item inside of blah is size of blah sub 0. So the size of the array blah is 24 bytes. The size of a single item inside of blah is 4 bytes. Using those two numbers, we can now figure out how many items are therefore inside of blah. So I'm gonna write that. Am I recording it for YouTube? Not really, Dandy. I'm literally just ranting for the sake of ranting. Therefore, the number of items inside of blah is size. Oh, what am I doing? Well, yeah, I didn't store them, so blah divided by the size of blah sub 0. There you go, man. Therefore, the number of items inside of blah is 6, and that is correct. I know, I get that way. I mean, don't get me wrong, it is going to be saved on YouTube. I am streaming to YouTube at the same time. But the fact that YouTube saves everything is just entirely coincidental. Alright, and I think that's it for my my little practice stream here. I actually do have some tutorial YouTube videos of C++, but they haven't gone very far for shit. Like, I'm literally not even... I don't even think I'm past comments in my videos, so it's not very far. Because I got bored. Alright, so I'm probably going to stream... No, I'm not going to promise you that. I was going to say that I'm going to stream a game in a little bit, but there's no promises on that. If you guys are on YouTube, don't forget to hit the like button. Other than that, you guys have a nice day, or a nice night, and thank you very much for watching.